So why do so many Industry 4.0 and digital transformation projects fail? Assembly lines may look like smooth operations, but it's chaos, full of disconnected systems, data silos, and clunky integrations. In this video, I show you why it's time to stop piling on multiple systems on top of your assembly line and start with a solid digital foundation. Let me introduce you to the concept of an assembly line operating system, a smarter way to build, scale, and future-proof your assembly line. So I've been in the trenches for the past 20 years, building production lines around the world. On this channel, I share with you my real-world experience for anyone looking to make a real impact in their factory. Whether you're a plant executive, an engineer on the floor, or anyone eager to expand their knowledge on this transformation topic. Let's dive in. Welcome to another Thursday Thought. I thought I would take this opportunity to share with you why I think assembly lines are far more complex than what they appear. And I think this leads to why there are a lot of failed digitization projects or Industry 4.0 projects that happen on an assembly line, because I think people take for granted the complexity that goes around a production line beyond just the physical machines. Especially when you walk down a production line and you see a bunch of automated stations and you see some assembly stations, manual stations, semi-automated stations, you kind of judge the assembly line for what it is and what you see there. Often what is misunderstood is that there are a lot of other systems, supporting systems around that production line to actually make it work. And the objective of this talk is to kind of talk through some of those systems and why I think they're much more complex than what people think. So to do this, I've prepared a couple of slides. So the first one is really around the three main elements that need to be brought together to make a production line. And that's people, objectives, and technologies. On the people side, we have obviously we have the managers, we have operators, we have all the maintenance technicians, logistics personnel, line supervisors, etc. Each of these people have different objectives. So obviously productivity, availability, quality, safety. We want to train operators faster. We also want to reduce work in progress on our shop floor to reduce the cost and improve cash flow on our production lines. And then there are a whole bunch of technologies that also need to be integrated together. So you think of things like ERP, MES, SCADA, PLC, etc., and all the different communication protocols, TCP, Profibus, DeviceNet, and that's just to name a few. There are a lot more technologies that need to be pieced together to make an assembly line work. And all of this needs to be put together and squashed into this production line to make it work. And this is where we end up with disconnected technologies and data silos that make the integration of all of these systems far more complex than what it may seem like at the beginning. And just for explanation purposes, I've got a dummy production line. So here I've got station 10, which is a manual process. Station 20 is an automatic process. Station 30 is a tightening operation. And then station 40 is a third-party machine that's integrated onto this production line. So think of a testing machine or some specialized leak test machine, for example. And then we obviously have a final station where the part is inspected. So let's build up this production line. So obviously we have some sort of transport system. So you think of a conveyor, an AGV, or a trolley system. We also then very often have sub-assembly processes that need to feed into the main line. So you think if you're assembling an axle, there's a corner that must be assembled, and that gets fed onto the main axle assembly line. If you have manual assembly stations, often we need some sort of worker guidance, and this could be anything from a piece of paper to some complex digital system that is implemented on the production line. And what I wanted to highlight here was every single unique color on this slide represents a different system or even a different vendor that is required to implement that system. So already we've got 3 different vendors that might play a role on this production line, and 4 if you consider the conveyor system. Then we have a bunch of automated machines. So you think of a press fit, gauging, testing machines, sometimes camera inspection stations. These are all typically PLC-driven stations. On the tightening side, we have obviously a wide variety of tightening tools. So you think of Atlas Copco, Bosch, De Sutter, Georges Renault, and the list goes on of the number of tightening tools that are able to be implemented on a production line. And all of this that I've collated into this green box typically represents what a machine builder or a line builder would deliver to a production facility. So think of an engine assembly line, an axle assembly line. It could be a medical device assembly line or a tractor assembly line. By and large, this is what a line builder or an assembly line builder would deliver to a customer. But obviously, the production line requires a lot more than just these elements. So let's move on. So obviously, every production line needs a sort of final buy-off, and this is where the system would go in and check all of the previous processes and make sure that everything is good before, for example, printing a final sticker. Many production facilities have an end-of-line quality inspection, and this could be anything from a piece of paper and a checkboard that is used, or even some sort of digital system where it's on a screen and the quality inspector will now press a series of buttons to confirm that everything is good. This is often linked to a rework or a teardown station. Often the rework and teardown station is an afterthought. So, for example, if they find a problem at the end of line quality inspection, or there's a problem with the buy-off, a product would typically go to a rework area or a teardown area. Or, for example, if one of the processes failed at the tightening station, it might go to a rework area, for example, to be either torn down to its child components, and those components are put back on the line, or reworked to a certain point where it gets delivered to the final customer, or anywhere in between. Another really critical function on production lines are, for example, these off-sequence production processes. So think of 5S. So every operator needs to make sure that they're performing their 5S on the station. On a regular basis, you need to do equipment verification. So this needs to be done from time to time, either based on cycles. For example, a tightening tool might need to be verified every 100,000 cycles. A leak test machine might need to be verified at the beginning of every single shift, as a simple example. And then we have probably what I think is the most important part of the production line, which is what we call process security, or the compliance control layer. So this is the rules of the production line. So for example, this is where you define the sequence. So a certain process must happen before another, and this is all defined in this process security and compliance control. Other rules, for example, might be a tightening operation may be allowed to be done 2 times and then scrapped on the 3rd time. Other tightening operations may only be allowed to be done once and then scrapped, for example. A leak test operation might need to be performed before a final check at the final inspection station, for example. These rules and compliance control mechanisms need to be built into this production line somehow. And often this is a combination of the line builder, the quality department, the product designer. They need to come together to define these rules and compliance control elements that need to be programmed into this production line. And then we have a number of, let's say, production data management tools. So things like OEE, so collecting data to calculate OEE. Many production lines have a big and-on display. So this is a display that sits above the production line that gives live performance data, obviously helps drive the performance of the production line. And this is now another system, often delivered by another IT company or machine building company. And then if you're using a digital worker guidance platform, typically they would have an integration tool and a configuration tool that allows you to set up these worker guidance. Or even if it's paper, you need to have a process engineering department that would now write out these work instructions and paste them onto the station. Again, that's another system. So I would group these systems as production systems. Moving on, we now have a bunch of data systems. So now this is where we start to collect data from either the PLC machines or the tightening tools, for example, and this gets collected in some sort of quality data repository system, and then that typically has its own kind of reporting system on top of that. Many production lines now need to record the images, so there's many cameras that are implemented on a production line, and these images need to be recorded so that the customers can go back and look at historical data to see if there is a problem and look at the specific image from a specific part. And now even more often, customers are requiring us to record things like the tightening curves or press fit curves from the tightening tools or press fit machines, for example. And then typically the quality department will have their own kind of reporting system. So if there's ever an issue in the field, they need to go back into some sort of data repository and have a look and see what data do they have for that particular component that's now has caused an issue in the field. And all of this I would sort of group as quality systems. And as you can see, there's already a number of different systems that are required to be pieced together and integrated together to make this production line work. And still, the production line is not yet functional because we still need to tell the production line what to build. So that comes in right at the beginning of the production line, and there's two main mechanisms. The one is, as I'm showing over here, is where we have fixed variants or batch build, and these variants need to be allocated into a queue. So in other words, I want to build 5 of this particular variant, 7 of the next variant, etc. This either needs to be manually inputted into a build queue or can be implemented, and a signal can be sent from, for example, an ERP system. These signals are then sent to the assembly stations as well as the sub-assembly stations, because sub-assembly stations need to be sequenced appropriately so that the right sub-assembly is fitted to the right assembly at the right station. And then we have the more complex sequencing of the line, which is what we call 𝘀cie𝗶𝗶𝗱, and this is where we are receiving a bill of materials, for example, from an ERP system, SAP as an example, and these bill of materials are then used to sequence the production line on what to build. And this is a typical automotive scenario where a customer would have custom ordered a vehicle, and they would have asked for very specific features on that particular vehicle, and so we need to build the components of an axle or an engine specifically for that particular customer. And this is all done through the 𝘀cie𝗶𝗶𝗃 very build string system, for example. And all of this is typically handled by the IT department. So at least we now are at the point where the production line can actually run. But obviously at the end of the production line, we now need to sequence the components that are produced on that production line into different donnages. We have to print out specific barcode labels and sheets of paper that would typically be delivered with the component to the end customer. This information needs to be fed back into your ERP system, as well as the warehouse management system, so that parts can be reordered and replenished onto the production line. And again, this is now typically handled by the IT department or logistics department or transportation systems. So as you can see, this is a very complex slide, and it's designed to be complex, specifically showcase the number of different systems and potentially vendors that are required to make a production line work. And all of this complexity needs to be pieced together in such a way that the line works efficiently. And obviously this results in a number of challenges and costs to make these production lines work. And I just wanted to highlight some of these challenges that you see on production lines from a day-to-day perspective. The first one is workforce challenges. And so this is really centered around skills and turnover of operators on the shop floor, which results in higher training costs and rework and waste. I think many environments are experiencing this very often. And because systems are rigid, it becomes very difficult to deal with this appropriately. So we have a lot of machine and operator inefficiency, and this is typically because we don't have enough data to measure the performance of the machines as well as the performance of the operators on the production line. One of the big ones for me is that production management teams are very reactive. So they use the data that they have to figure out what happened yesterday. They're not really using data to figure out how to prevent problems tomorrow. So they're not very proactive in solving problems that might happen tomorrow. They're very reactive in preventing problems that happened yesterday. And I think this is one of the big challenges of how we should be using data more effectively. Often, because of these disconnected systems, you see that production lines are very inflexible because they're hard coded, and the integration between the different systems is really fixed. And so making changes on a production line becomes very challenging. Again, similar reasons, but because of these disconnected systems, you don't have deep visibility into the granular data on a shop floor because there's so many different systems that need to work together. And this often results in an inconsistent quality, a lot of effort to figure out root cause analysis of what's actually going on. And many systems are thinking about rework strategies only at the end, and they're not building in rework strategies right from the beginning. And already, as described, I think one of the biggest challenges that we see is these disconnected systems and data silos that result in a lot of the problems that I'm showing on the slide. So how do you fix this? And I think this picture illustrates a lot of the challenges that people have experienced in trying to solve these disconnected systems on the shop floor. And what happens is they have a production line, and they and what happens is customers spend a lot of time and effort putting systems on top of these existing production lines and building more and more systems on top of the production line, where the production line itself, its foundation has not been designed for all of these heavy systems on top of it. And I use this picture to illustrate that. So I call this the golden roof on a shack analogy. So think of it as these expensive IT systems that are being loaded on top of a production line, like a golden roof. And the problem with the golden roof is that it's very expensive and it becomes extremely heavy. The more gold you put onto it, the heavier it becomes. And if a foundation is not strong enough to actually take the load of all of these systems on top of it, eventually it's going to come crumbling down. And for me, this is one of the key reasons why digitization transformation projects on the shop floor have failed, is because they've failed to understand the architecture and the foundation on which these production lines are built. And they just start to pile on these systems on top of it. So what have we learned over the last couple of years building more than 3,000 assembly systems? And over the years, what we've realized is that we actually need to build a very strong digital foundation before we start putting the machines on top of it. And that's what we've done. We've built an assembly line operating system. And basically what this is this digital infrastructure that forms the foundation of the production line. And then you can build your machines on top of that. And that allows us to scale and really expand the digitization of these production lines with many different systems. And ultimately, that is what Odin Workstation is for our customers, is this operating system, which is basically this digital foundation on which you can build all of your equipment on top of that. So how does Odin Workstation work? So let's go back to our analogy of the assembly line that I shared earlier, that would typically be delivered by a line builder. We obviously have an existing ERP or MES system. And basically what Odin Workstation is this layer in between that we call an operating system, that is a seamless integration between the shop floor and the business platforms and business systems that exist in a factory. So let's start with what are the main functions within Odin Workstation. So the first one is this no-code process planning and worker guidance configuration tool. So this is where we set up the process and the work instructions. And basically, this is where all of the dynamic work instructions that the operator might see are configured and set up inside the system. And most importantly, this is connected to the process security and compliance control leg. So we don't have a separate system that determines the compliance and the process security layer. All of that stuff is built into work instructions. So essentially, as you build out the work instructions in this no-code platform, you're actually defining the process security and compliance control. And why that's so important is that it allows industrial engineers and process engineers that have an intimate knowledge of the critical processes that need to be implemented on a production line. And as they build out the work instructions, they're actually coding these security layers into the production line through the no-code platform. That becomes a very powerful tool where we now don't have PLC programmers programming in compliance control. We actually have industrial engineers or process engineers that have intimate knowledge programming this compliance control. Built into that, we're now able to use that compliance control to control third-party systems and third-party machines. So it doesn't only have to be Jendamark specific machines, it could be anyone's machine. And what that means is that we can then pick the best in class machines that can be strung together to form an assembly line. You don't have to buy everything from one machine builder. So you could have station 1 from the best in class manual machines, you could have station 20 from another best in class automatic machines, and so on. And because we're have aggregated the overarching process compliance out of the production line itself, we can integrate these machines into this compliance control layer and take control of these machines. And more powerfully, as I've already mentioned, is the control and sequencing of this process is done by process engineers, not PLC people. And built into that whole thing right from the beginning is the rework planning module. So this means that based on a failure mode that might happen in a process, we can automatically build in the rework element that needs to happen. So this could be, if a bolt fails, scrap the component, it doesn't go to rework. Whereas if a bolt fails on another process, it might be allowed to go to rework. And so by combining the process planning together with the rework planning in this process security and compliance layer, we're now able to take control of the exceptions that happen on a production line. In other words, we're taking care of reality. On any production line, we always have to prepare for these problems that are going to be faced on a production line. The next module that I'll share with you on Odin Workstation is the quality systems and lean management. So the first part of that is the final buy-off. So built into the system is at the final station, Odin Workstation is doing a compliance check to make sure that every single process that was expected is actually completed, and completed with a pass signal, and we've got all of the data recorded accordingly. And that's one of the functions that's built in. You don't need to have a third-party system do that. The next one is end-of-line quality inspection app. So we have basically a tablet that a customer can basically install at the end of the production line, and there's a list of tasks that need to be checked on that are displayed on the tablet, and the quality inspection engineer can go and actually take a bunch of photos of the element that is actually checked, so that if there is ever a problem in the field, they can very quickly go back to the specific product, look at the individual photos that were taken to see, was the problem, did the problem happen before the product left the production line, or was it after it left the production line within a matter of minutes. And then these scheduled tasks, things like 5S, equipment verification, batch box scanning. So if you want to scan the batch of bolts that are used on an engine, for example, so that if there's ever a recall campaign required because of those specific bolts, you're able to identify exactly which engines were infected by that specific batch of bolts. That function is now built into the system. You don't need a third-party system to actually do that. And then we have the sequencing of the line, and we have obviously the two kinds, the batch build side of things, where you can build a queue based on a specific set of variants that need to be built, as well as the just interface side of things. So where we are able to sequence the production line based on a specific unique bill of materials that might have been ordered by a customer. And finally, I think probably the most powerful part of all of this is that all of the data, whether it be the build sequence data right from the beginning to the process data that might have been collected, the quality data, the cycle time data, the performance data, OEE data, operator cycle time, operator performance, etc., torque curves and images are all collected in one unified data platform. And this is really critical because it allows us to firstly pass the right necessary data to third-party systems, for example, warehouse management systems or the existing ERP system. And more importantly, we're now able to make very useful reporting and analytics as well as predictions because we have all of the data collected in one place in the right context that allows us to make analytics and predictions much more efficiently and make the production line a lot more scalable because we've built in this foundational layer that we call an assembly line operating system. And then finally, one of the newest features we've implemented is this AI virtual devices module. And this is where we're using AI computer vision to actually remove physical devices on a production line, for example, push buttons, pick to lights, because we're now able to track hands. We don't need push buttons. We can just track the finger going into a particular zone. We're also able to track the position of objects, for example, a bolting tool in 3D space, and making sure the bolting tool is in the right position before we enable it. In this way, we're able to control the sequences. And this previously was only able to be done by adding physical devices, for example, bolting tool manipulators with sensors to detect the position. So this is a snapshot of what Odin Workstation is and why we call it an operating system for an assembly line. We've implemented Odin Workstation in a number of countries, a number of locations around the world. In fact, there's more than 70 production lines now using Odin Workstation with many different customers in different locations. around the world. So in conclusion, I just wanted to end off with saying that I think that we need to rethink the way assembly lines are actually designed and think of it from a digital perspective first, and not dive into designing the machines, adding PLC systems, and then trying to integrate MES and ERP systems on top of that. I think it's really critical that when we're designing production lines and specifically assembly lines, we think about the digital side first, the digital infrastructure, the digital backbone, build the machines on top of that, and that allows us to scale and use the data much more effectively, whether it be for predictions, AI analysis, implementing large language models onto the production line. By rethinking the way we design the infrastructure of a production line allows us to scale and expand into the future.